This is an example for a right-tailed test for the population mean mu. So in this example, the average amount of coffee consumed by a working adult per day is claimed to be greater than 32 ounces. We all love coffee, and so this is a great example. To verify the claim, 10 adults are randomly selected and are asked about their daily coffee consumption, and the data is shown below. So I have the data, now I have to verify the claim. So first you have to identify what we are testing for. We are testing for mu, which is the average amount of coffee consumed by a working adult per day. Now the claim is mu is greater than 32 ounces. Now observe the claim, it does not have an equal to sign. Therefore this must belong in the alternative. So the claim belongs in the alternative. Now that we've identified the claim, the null is the exact opposite of the alternative, so the null is less than, mu is less than or equal to 32. That completes step 1 of our test. Step 2 is to recognize the value of alpha. So alpha is 0.05. So if alpha is 0.05, then the level of confidence is 100 times 1 minus alpha %. This is the amount of confidence corresponding to a level of confidence, level of significance alpha. And that is 100 times 1 minus 0.05%, and that gets 95%. Step 3, we'll have to find the test statistic. The test statistic is given by this formula, x bar minus mu naught over s over square root of n. Mu naught is the claimed value, and we claim it's greater than 32 ounces, so mu naught is 32. We have to find x bar and s, for which we'll need the data. So here I have the data. I'd go up here, press start, press 1. I could actually clear this list, so press 4, clear list 1. I want to erase all the information in the list, so I'm clearing it. After I clear it, I could go back and enter stuff. So it's 24, 16, 18, 20, 34, 48, 40, 32, 26, and 30. Second mode to exit. Now I could press start, go over to calculate and select one variable statistics of the data in list 1. Press enter. The mean is 28.8 ounces and the standard deviation is 10.119. So I could write it as an approximation as 28.8 and 10.12. So x bar is 28.8 and s is 10.12. N, we know we're observing 10 adults, so the sample size is 10. So the test statistic is 28.8 minus minus 32, which is mu naught, divided by the standard deviation 10.12 over square root of 10. So you could find the test statistic using the calculator as follows: 28.8 minus 32 divided by S, which is 10.12, divided by square root of 10, close paren, enter, get negative 0.9999. So we have found the test statistic, which is negative 0.9999. So the next step is to recognize or identify the distribution of the test statistic. The test statistic for this particular test has a t-distribution with df, which is the parameter, n minus 1, so 10 minus 1, which is 9. If you're performing a one-sample test for mean, the test statistic will always have a t-distribution with degrees of freedom n minus 1. So we have the test statistic and its distribution, so we can find the conclusion. The last step is the conclusion. As always, you can find a conclusion using either the critical value method or the p-value method. I'll do both methods here, but in practice one is sufficient. So the test statistic has a t-distribution, and t-distribution looks very much like a normal, so that is my distribution. 0 is in the middle. And this is a right tail test, so the rejection region will be on the right side. So I'm going to sketch the rejection region on the right side. That is my critical value. The area of the rejection region is equal to alpha, because I have only one rejection region, and the area of the rejection region must always equal to the value of the level of significance, which is alpha. So in this case it is 0.05. So if the area above is alpha, the area above the critical value is alpha, the area below the critical value, or the quantile, is 1 minus alpha, so we denote this as t 1 minus alpha, which is the area below, comma df. And I could find this critical value using inverse t. 1 minus 0.05 is 0.95, comma df, which is 9, 10 minus 1. So the critical value is 0.95, comma 9, and I end up getting 1.833. Now, have to find if I will reject the null or not. The test statistic was negative 0.9999. So that is the test statistic from step 3, and this is the critical value. Did the test statistic cross over and fall in this rejection region? So the test statistic did not fall in the rejection region. In other words, the test statistic is not greater than the critical value. So since the test statistic doesn't fall in the rejection region or the critical region, we fail to reject the null with 95% confidence. So this would imply we fail to reject null with 95% confidence. Why 95? Because we selected an alpha of 0.05. An alpha of 0.05 would imply 95% confidence. So if you do the p-value method, you have to find the p-value for a right tail test, the p-value is the area above the test statistic. So I know the test statistic is negative 0.999, so which is somewhere over there. And I'd like to find the area above, and if I find that area will be the p-value. How do I find it? Well, since the area is the probability under the probability and it's the area under the curve, so you can use CDF functions, and since the test statistic has a t-distribution, you'll be using a t-CDF. So t-CDF, the starting point or the lower end point is minus 0.9999, and the upper end point is infinity, so E99, the degrees of freedom is 9, which is 10 minus 1. And we could do this using a calculator. So press second vase, number 6, negative 0.9999, comma, second comma, which will give you the E, then 99, comma 9, close paren, press enter. The p-value is 0.82825. I can write it as 0.8283. Now we have to ask a question: is p-value less than or equal to alpha? If I say yes, we reject the null. If I say no, we fail to reject null. So clearly, the p-value is 0.8283, alpha is 0.05. 0.8283 is not less than or equal to 0.05, so we fail to reject null. It's the same conclusion that we had previously. So there is the concept of finding support toward data and support toward the null and support toward the alternative. So the evidence or probabilistic evidence that we have toward the alternative is given by 1 minus p-value, and the probabilistic evidence that we have toward the null is the p-value itself. So 1 minus 0.8283 is 0.1717. And p-value is 0.8283, therefore the evidence toward the null is 0.8283. So what this means is, if I've repeated this test over and over again with, say, different samples, suppose I repeat it for 100 times, 83 out of those 100 times I'm going to agree with the null, and the remaining 17% I'm going to agree with the alternative. If 83% of the time I agree with the null, then it tells me that I find the null to be more likely to be true compared to the alternative, and which is why we fail to reject the null in this particular case. That is an informal way of interpreting the p-value. A formal way is p-value is a measure of error. So if you happen to reject the null, hypothetically speaking, how much error would I be making? So error made when the null is rejected is about 0.8283. So hypothetically speaking, if I've rejected the null, there is an 82.83% chance of an error that I'll be making, which is a huge amount of error. So you should not be rejecting the null, so we fail to reject the null. So this is the formal interpretation of p-value. The support the evidence toward null and evidence toward alternative, the finding probabilistic evidence is another way of interpreting the p-value, but it's not very formal. It's an informal way of interpreting the p-value. It is the amount of support you get towards the null or the alternative. The formal way is sort of related to the error in a hypothesis test. That being said, now that we've failed to reject the null, our original statement from step 1 is that mu is less than or equal to 32 versus mu greater than 32. This is from step 1, and that is our claim. And data, after performing this test, concludes that we failed to reject the null. So we have found evidence toward the null. So since we failed to reject null, data is pointing toward the null, but the claim is the alternative. So this would imply that the claim is false. So in this problem, the claim is false because the claim is represented by the alternative, but we found evidence toward the null. Therefore, we conclude that the claim is false. That is how you perform a right-tail test for population mean. This can also be done using a calculator, and it's quite straightforward. So I'll show you how that can be done, or how this test can be done using a calculator. So press start, go over to tests, select option 2, which is a t-test. I have the data in list 1, so select that. Automatically it knows that the data is in list 1. Now you have to enter the claimed value, which is 32. The data is in list 1, so I go to select the alternative. This is not a two-tailed test. If I look at the alternative is mu greater than mu naught, so I select option number 3, then I hit calculate, and that is my information. T is -1, the test statistic is -1, and what we had was -0.9999, which is approximately -1, and the p-value is 0.8282. That's exactly what I have over there. The mean is 28.8 and the standard deviation is 10.12. If you don't have the data, but you have only statistics from the data, so you could go to t-test again, but you would select statistics, press enter there, you would enter the claims value, you would enter the mean. The calculator recognizes the mean that I have from the data, so it's 28.8, and the standard deviation is 10.12, the sample size is 10, and we are selecting a right-tail test, and if you hit calculate, you'd still get the same answer. If you want to sketch the p-value, you'd repeat the process and select number 2, and instead of calculating, you would say draw. If you hit draw, it's going to sketch out the p-value, and the p-value is the area above the test statistic, and that's exactly what you see over there. And if you recall, that's the same picture that I drew over here, because mine's not as pretty as the one that the calculator gives us, but the concept is the same. So that is how you perform a right-tail test for population mean using a calculator and using the manual approach. Thank you for watching.